All right, on our third functions lecture, we want to talk about why Mr. Creswell laughs all the time. We want to talk about inverse functions, how to find them, and be able to verify that they're inverses of functions. So I'm going to go through how to find the inverse of a function. Well, the notation for inverse is this little superscript -1. That means, hey, find the inverse of function f of x. And so it's not raised to the -1 power, it's just a notation. Do you have anything you want to say on that?
No.
All right. So if our function is x over x plus 1, I know this probably isn't the greatest mathematically, but let's treat f of x as if it were a y. And y equals x over x plus 1. In order to find the inverse of this, anywhere that we see a y, we're going to replace it with an x. And anywhere that we see an x, we're going to replace those with y's. And then we solve this equation for y. And Mr. Creswell on the break there said, hey, multiply both sides by y plus 1. So we've got x times y plus 1 equals y. And then he said distribute the x through, so xy plus x equals y. And then in order to solve for y, we have to have all the y's on one side of the equal sign and everything else on the other, and everything that doesn't have a y. So essentially, I'm going to bring this y over here by subtracting, and this x, I'm going to go over the other side. So we'll have xy minus y equals, what we brought this x over, the negative x. All right, factor the y's out of here, because both terms have a y in it. So we'll have y times x minus 1 equals negative x. And to get y by itself, I'm going to divide by this parenthesis. So in other words, y equals negative x divided by that parenthesis, which was x minus 1. So this is the inverse of that. Or you could say that equals the inverse function. So negative x over x minus 1. Negative x over x minus 1. So all right, so what's the domain of this thing? Well, the domain is going to be anything, x can be anything except it can't be 1. Because 1 minus 1 makes 0 on the bottom of it. So far, my domain is anything but 1. Everything else on the number line works. But this function came from this one. Are there any restrictions on the original one? Yeah, x can't be negative 1. And so there's an inherited part of the domain that you inherit from the original function. Like I inherited my beautiful hair from somewhere. So what is the domain of this function? Well, it's everything except negative 1 and 1. So you start out here at negative infinity, and you go till you get to negative 1, jump over it, go till you get to 1, jump over it, and go till you get to infinity. So we'd probably write that negative infinity until you get really close to negative 1, jump over it, negative 1, go till you get to 1, jump over it, and then 1 to infinity. I don't always put the little union signs in, do you, Mr. President?
No.
Yeah, sometimes I don't.
Good to know.
All right. Now, the horizontal line test, sometimes they'll ask you, hey, is the inverse of this function also going to be a function? And remember, to find out if this was a function, we use the vertical line test. To see if its inverse is a function, we use the horizontal line test. So if we graph that thing and we take horizontal lines, all of our horizontal lines only hit the graph at one spot. So if they only hit at one spot, its inverse is going to be a function. Well, that one didn't exactly go. Yeah. All right, I think it's your baby there.
Okay, so if we want to check and see if two functions are inverses, we have a little rule here. And it says this: if two functions are inverses, then g of f of x equals f of g of x. Remember, these are composites of functions. And those both have to be equal to x, also known as the identity function. So let's check g of f of x first. So g of f of x So that means that I'm going to put f of x wherever I see an x in G. Okay, so this is going to be the cubed root of x cubed plus 1 minus 1.
Where'd the minus 1 come from?
That minus 1 is left over here, right? Because we put the function in to
I
x.
got it.
Alright, okay.
Thank you.
Alright. Let's simplify this real quick. The 1's go away, right? So I've got the cubed root. I'm going to write that to the 1/3 power. So I hope it's okay if I do 2 steps at once here. This is going to be x cubed to the 1/3 power. And we learned from exponent rules that we can multiply those exponents. So this is just going to end up being x. Oh, bingo. I think that's what we wanted, right?
Yeah, I always just remember the cube and the cube. Well, these canceled, right? The
right.
plus 1, minus 1.
Yep.
And the cube and the cube root cancel each other out. That's how I remember it. But that's okay. Go with it. I like your 1/3. It's beautiful. Keep on trucking.
Okay, let's go to the next one. I can get rid of all this junk here.
I don't care.
Good to go. Okay. So now we want to check. I think we just did f of g. Do we want to do g of f?
You did g of f. Because you stuck this in.
Right. So now let's do f of g. Alright, f of g of x means I'm going to put g of x wherever I see an x in f. Okay. So this is going to be the cubed root of x minus 1. That's my g. That whole thing cubed.
That cube right there came from this one, right?
Exactly.
Okay.
Yeah. Plus 1. Okay, as Mr. Kelly pointed out before, the cube root and the cube kind of cancel each other out, right? So we're left with just whatever's left over inside the cube root, which is x minus 1, plus 1, negative 1 plus 1 are gone, so I'll be left with just x, which is our identity function.
Yeah.
So,
since g of f equals x and f of g equals x, those two must be inverses.
yes.
All right, thanks for taking our class.